Alright, testing 1, 2, 3, testing 1, 2, 3. Yep, I see stuff moving. That's probably a good sign. Greetings, travelers. Couple minutes late, my apologies. Normally we don't have the multi-stream thing going, but today we do, and it's actually a little bit harder to get things streaming to Facebook than I thought it would, but got it all figured out. So we are all set. Hello, chat. Hello, internet. Greetings from the void. No, this is not the void. This is our wonderful studio. It's also what we like to call our starship. This is our Astral Observatory, and we'll be doing a planetarium show for free here on the internet. For all of you to enjoy, hopefully. We are joined by... well, looks like only one guest at the moment. We had two, now we only have one. We have Sirius, our faithful companion, our dachshund, and we also have Alcyone, our faithful kitty, who has skedaddled from our observatory, and that is quite alright. Let's fade this out. There we go. Well, what do we have here? That is not the right screen. Let's try that again. Stellarium. Hello? Yep, there we go. Perfect. So, before we do begin, I just wanted to kind of let you know what we're going to be doing. We're going to be looking at the sky with this software right here. This is our planetarium. And the dog, of course, wants attention. As with children, live animals are always a fun thing to do live streams with. We're just going to have to roll with it. Excuse the growling puppy. He just wants more snackies. We do have multiple softwares we'll be using. We'll be using Stellarium, which is free to download, stellarium.org. I'm not affiliated, just a fan of it. That's this software here. This right here is Universe Sandbox. You can find it over on Steam if you'd like, and we'll be using it for some more three-dimensional stuff. Example right here, this is our solar system with Mr. Sun way in the middle here. So we'll be bouncing around to that as well. And finally, we do have just a simple web browser that we'll use for looking at just general stuff. Now, whenever we do our news piece or whenever we do our planetarium shows like this, we do usually start off with something called astronomy picture of the day. And that is this. It is a very simple, very ancient looking website because it kind of is. First one online in 1995. And what they put up is every day something new and hopefully exciting to you. It usually is astronomy. Sometimes it is a visual or a graphic, but it's always astronomy based. Today's is actually kind of helpful. Talks about the moon phases. So this is actually a video that they've embedded in the website. Really cool. Does talk about the moon libration, I should say. And how the moon wobbles as it orbits around our planet Earth and keeps the same face, or what we call tidally locked. And more helpful, it does have everything labeled as this goes along, so that's really cool to see. Now this archive does go back to 1995. There is some weird wonkiness with certain web browsers not being able to prefetch or access older links within it. I'm not sure why that is, but do your best to try to dig through it. As I said, the archive does go back to 95. It does actually say that this early archive goes back to 2015, but there's a lot more hidden as you go back if you click on full archive. And as I said, you can, pick a day, do something kind of fun if you have a family or friends or kids or whatever it is. Pick their birthday and take a look at whatever picture they put up on that day. And it does, again, only go back to 1995, so if you're older than 95, sorry, there's no picture for you there. I was able to tune in. Still a little bit sleepy. Sorry if I'm not as talkative during stream. That is okay. Welcome to our stream. Glad to have you along for the ride. At least somebody's here. That's what matters. You could be sleepy or awake. It is totally fine. Having spent many, many years in a planetarium, sleepy is sometimes what happens when you stare from a very comfortable chair in a very dark room staring at stars. In a planetarium, it's not uncommon to find people falling asleep, not because you're boring, but because it's very comforting, very relaxing, and usually when you're looking at the stars, it's just kind of a nice feeling. So, as I mentioned, you will hear doggy growls in the background. I do apologize for that. Sirius is just not cooperating today. But that is okay. So this is from yesterday, it looks like. Again, a really, really cool thing. If you don't know what you're seeing, you can usually click on it, and then it'll blow up the picture like this. Very, very large. Very beautiful. You see lots of beautiful young, this is going to sound strange, young, hot blue stars. Because that's the way it goes. When you talk about stars, they go on a color spectrum, and the color actually reveals the temperature of the star, and usually the age of the star as well. Young stars tend to be very young, very hot, very blue in color. Older stars tend to be more red in color, so you've got a red-colored star kind of in this upper region here. You got a beautiful nebula in the background, so a nebula is a cloud of gas and dust. Lots of molluscules floating around in space. Usually after a star or multiple stars explode, they leave behind nebulae. And over time, these then congeal and coagulate into other star systems, and you get more and more complicated planets. So instead of just gas giants, you start getting rocky worlds and heavier elements on the periodic table. This is just a really, really cool picture. Again, if you don't know what you're actually looking at, there's actually a description at the bottom. Kind of helpful. Also has lots of links, either to NASA pages or to other astronomy picture of the day pages, or to Wikipedia or other, online sources for data. So if you don't know what it is, again, you can click on it and it'll bring you to stuff like this one's called a tarantula nebula. What's a tarantula? I don't know. Here it is. Oh god, why did I do that? I hate spiders. Pro tip, I'm terrified of spiders. I don't know why I clicked that. Anyway, so that's astronomy picture of the day. Feel free to look that up in whatever browser you'd like to use. And I believe there's actually an app you can download for most devices, and it actually will change your background to today's picture if there is one. So that's just kind of a heads up on that. Hey, buddy. You good boy? You want to play? No, we can't play right now, buddy. We gotta do a show. You can help at the show, though. Here we are once again in our planetarium. Now, we've artificially created this, of course. We don't have anything along the horizon, so everything that's green, that is the ground, that is the Earth itself, and then everything above, as we zoom back up, Sirius. Good God. Where was I? My God, little dog, lay down. He really wants to be in the show, everybody. Come here, buddy. Come sit on my lap. Let's do the planetarium show. Come on, buddy. Ugh. Sorry, no camera, but I do have a puppy in my hand. He is a little grumpy. I think it's because he thinks I have more snackies, but that's not happening. The only snacky I have is for your minds. The snacky is information about the stars. Now, Please don't chew on my microphone. In our planetarium, we will be using directions, so they are already labeled on the dome, but obviously in real life, you cannot do that. There are no artificial labels like that in the sky. Good thing to always know is the sun rises in the east and sets in the west, so we have the sun right here in our planetarium dome. Which means, if you watch it, it's actually been traveling. This has actually been on all day on my planetarium, on my computer here. And it's been traveling from this direction across, so it's rising in the east, setting in the west. This is the current sky the way it is right now outside, minus the clouds. And we do have atmosphere. Now, if we didn't have an atmosphere, one, we'd all be dead. Two, the sky would look a little different. That is not what I wanted. That's the one I wanted. There we go. Without the Earth's atmosphere diffracting sunlight around, the sky would look more like this. You'd see a very bright object in the sky, the sun, of course, and you'd actually be able to see planets and stars and the Milky Way and all the other things that you normally see at night, but it'd be out the day. Thanks to our atmosphere, one, we can breathe and exist. Two, you get the blue sky. Of course, during sunrise and sunset, the longer wavelengths, so when I speak of wavelengths, I speak of colors, the color spectrum. So when you see a rainbow, that's sunlight diffracting through water. And so you get red, orange, yellow, green, blue, indigo, and violet. This, of course, is the color of the rainbow, and that's, again, colors you see with stars as well. Blue stars hot, red stars cold, yellow stars like our sun, kind of smack dab in the middle when it comes to stars and their temperatures. Again, we are looking south right now, south-southwest it looks like. The moon is actually out. Now, the moon is visible during the day if you've never actually looked for it. There are times you can see the moon. If you were to walk outside right now, you would see a slight little crescent moon to the west of the sun in the sky. The moon is going to be entering into what is called new moon phase, which starts the cycle of the moon all over again. Now, the word month, actually Venus is also out. Sometimes you can see Venus during the daytime. You really want to be careful when you're looking anywhere in this region near the sun. You don't want to stare at the sun. That's how you hurt your eyes. Even if you have sunglasses on, it's a terrible idea. Please do not do that. Let's talk about the moon. The moon is our celestial companion. Again, if you have any questions at any point, feel free to post them in chat. I will stop. My mind usually wanders throughout shows, so I'm happy answering questions as we go along. Really quickly, we're going to jump and talk about the moon. And we kind of already saw this in the video from Astronomy Picture of the Day, but we're going to take a look at this again with this little applet that I found, which is really, really cool. It shows the moon phases. There's a little pink marker on the middle of the moon, and you'll see it's pointing straight at the Earth. The moon is called tidally locked. It means the same side is always facing the Earth. You cannot see the back side of the moon, but do not call it the dark side of the moon because it does receive sunlight, and we'll talk about that in just a second. When you see the moon, what you're actually seeing is sunlight reflecting off the moon's surface. As the moon goes around the Earth, it goes through phases. When the moon is in the sky with the sun, it is in what is called new moon phase. It is the darkened phase, the dark phase, because you don't see it at night and you don't see it during the day. You just don't see the moon, really, at all. Now, as the moon begins to orbit around the Earth, you will notice the bright side will be on the right side of the moon. We call that a waxing moon. When the moon has gone 1/4 of the way around the Earth, it hits what is called first quarter moon, and you see about half the face. The moon is continuously reflecting the sun, reflecting the sunlight. Yeah, so the sunlight actually is the reason we see the moon. The moon doesn't create its own light. It has an albedo, which actually means reflectivity. Excuse me. And depending on the angle between us and the moon and the sun, we see different amounts of sunlight being reflected back towards us. There's our first quarter moon. After first quarter, the moon continues to appear to get bigger and bigger and brighter. We call this a gibbous phase, in this case the waxing gibbous. We've gone almost an entire 2 weeks from new moon to where we are now, and I will stop this here in just a second. This is when we get to what is called full moon phase. Now, full moon is when the moon rises at the same time the sun is setting. They are opposite of each other in the sky. The moon is halfway around the Earth in its orbit. And you see the entire face of the moon illuminated. During this phase, this is where you will find, occasionally, the moon going through what is called a lunar eclipse. Lunar eclipses are totally fine to see without protection. Solar eclipses, when the sun gets covered up, those you need protection or else you're going to hurt your eyes. Lunar eclipses are totally fine. There was a lunar eclipse a few weeks ago, visible in certain parts of the planet. Then the reverse phases happen, so to speak. You go back to gibbous phase. This time it's called a waning gibbous, because the moon is now getting dimmer and dimmer and dimmer. The bright side is now on the left side. Bright side on the right side, waxing. Bright side on the left side, waning. Waning gibbous becomes a waning crescent. After the third quarter, there we go, 3/4 of the way around the planet Earth. And now you'll see the sun and the moon will be once again in the sky together, but the moon is on the western side of the sun from our point of view, and this is actually about the same phase we have outside right now. You'll see something like this. So the moon and the sun almost together, exactly in the same part of the sky. This is again approaching new moon phase. This is the waning crescent. That's what we like to call this little section of our imaginary spaceship. There we go. New moon phase. New moon is where you can find solar eclipses if the sun and the moon happen to line up. The moon happens to be the right size to cover up the entire disk of the sun. And the cycle again begins anew. Now, the word month actually comes from this cycle. And the word Monday comes from the moon as well. All 7 days of the week do refer to what are called the 7 classical planets. Now, they're not actually all planets by what we call them today. The sun, the moon, and 5 other objects were considered planetes, or wanderers, vagabonds in the nighttime sky and the daytime sky. And that's the sun and the moon, which obviously we don't call them planets today. And then the planets Mercury, Venus, Mars, Jupiter, and Saturn. So each of the days of the week refers to one of these objects. So sun, Sunday, moon, Monday. And then again, some language stuff happens. Yeah, it's based on Latin words. Yep, chat, you are correct. If you go back far enough, you have, martes, if you speak Spanish. Martes is Tuesday. Well, that's referring to Mars. Wednesday is going to be Mercury. Thursday, jueves, Jupiter. Thursday. Friday's going to be Venus, and Saturn, Saturn's Day. So 7 days of the week, 7 classical planets. Again, the moon is not a planet, neither is the sun. The sun is what we call a star today. And the moon, as it goes around our planet, goes through these wonderful phases. That is how they move. Or how our eyes perceive, I should say, the moon as it goes around. We'll look at the planets a little bit here. Just a second. Let's come back to this. As I mentioned, Venus is actually out, and sometimes you can see Venus without a telescope. During the daytime, it is a very reflective planet. It's the brightest of the planets. When it comes to reflecting back sunlight, when you see a planet in the sky, you're not actually seeing the planet glowing of its own accord. You're seeing the planet reflecting back sunlight. Now, Venus has a very thick atmosphere and reflects a huge amount of sunlight back to us, and so it looks very, very bright in the sky. And of the planets that do reflect back sunlight to us, it's the one that's actually closest, reflects the most amount of light, has a high albedo, as it's called. And so it looks very, very bright. Now, it's either in the extreme morning, right before the sun rises, or right after the sun sets. Some people call it the morning star, some people call it the evening star. It is neither. It's not a star, it's a planet. It just happens to be very, very, very bright. Now, unfortunately, for the next few months, most of the planets are going to be really close to the sun, and kind of hard to see at night. There are some planets you can see without a telescope. Again, Mercury, Venus, Mars, Jupiter, and Saturn are all visible without a telescope. But unfortunately, it all depends on where we all are in our orbits, whether you're going to be able to see them or not. Now, this is right at sunset. The sun is setting in the western sky, and the sky will begin to change from this beautiful orangey red color to the standard evening sky. As we mentioned earlier, the moon will be in new moon phase for the next few evenings. That's the best time you want to go out to look at the sky. Whenever you have a moon in the sky, the moon is beautiful to see, but it blocks out a lot of the fainter objects that are in the sky. So the planets will be easy, but if you have a telescope or some binoculars and want to look at some, quote, deep sky objects, you want the moon to be gone from the sky. Now, just a few evenings ago, I did put up a video about this triple conjunction of planets in the western sky. So the sun's still setting, and already we see this going on. We're going to go ahead and talk about these planets, and then we'll talk more about the structure of everything. As we zoom in, you see there's a triangle of planets in the sky in the west. I did mention that in the video. In fact, I did use this software. You can see they're very, very, very low on the horizon. If you have any buildings or big hills in the way, you might not be able to see one of them, which is Saturn, the lowest of these three at the moment. Just a few evenings ago on the 9th, Mercury was next to Saturn down here, and it's actually progressed its way up to where it is tonight, where it will be parallel to Jupiter. And of course, after making all this video and being super excited about it, I didn't take any pictures of it because I couldn't, because it snowed and got really cloudy. So hopefully wherever you happen to be, you got to see this. Now, let's talk about these planets. Obviously, the closest planet to the sun is the planet Mercury. It's named for the messenger god, Hermes, or Mercury, Greek or Roman, depending on which way you want to look at it. Speedy moving. Good name for it. Mercury's only going to be in the sky for a couple of weeks. It should be gone by, like, the second week of February. It'll be totally gone from the sky. So if you haven't seen it before, go out there and look at it. It's just going to be a kind of a purpley colored, non-twinkling object. That is the most important thing to remember. Stars twinkle, 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 little star. Planets do not twinkle in the nighttime sky. Next to Mercury, you see the planet Jupiter. Jupiter will be the brightest of these three particular objects in the western sky. Jupiter is the king of the planets, the king of the Roman god Zeus in Greek. We won't really be able to zoom in too much here. But when you do look at Jupiter through a telescope, you do get to see not one, not two, not three, but hopefully all four of these, what we call the Galilean satellites, or the Galilean moons. They are named for Galileo Galilei. 1610 discovered these things, orbiting around the planet. Their names are Io, Europa, Ganymede, and Callisto. Io is the innermost of these four. Then you got Europa, and Ganymede is the largest satellite in the entire solar system. Callisto rounds out these four, and you can actually watch them night after night as they orbit around the planet Jupiter. Jupiter itself, you're not actually looking at the surface, you're looking at the upper atmosphere. Tonight, if you do have a telescope and are lucky enough to see this, the Great Red Spot will be visible. That's this huge hurricane-like storm. You could fit the Earth across it 3.5, 4 times, give or take. Think about that. When we have hurricanes here, they can be very devastating, and they only affect small locations, or typhoons they're called on the other side of the planet. But again, they only affect certain areas, and that's kind of the same idea here. It's only affecting a certain portion of the atmosphere of this planet. But Jupiter's so much bigger than us. It would actually be bigger than our planet. This one storm, 4 times the size of the planet. It's huge. It's a huge red-colored storm in the southern hemisphere of the planet. These are all clouds. Jupiter does have what's called differential rotation. The equator rotates at a slight different speed than the North and South Pole. You get these very interesting cloud structures here. Of the 4 moons, just wanted to mention 2 of them real fast. Io is always kind of fun because it's a volcanic moon, so if you like volcanism and studying lava flows and things like that, study the moon Io, or Io. It's a little too close to the planet Jupiter, and the gravity of this large planet is literally shredding this little moon apart. So its surface is always changing. Europa is also being affected by Jupiter's gravity, but it's not being shredded apart. It is being heated up. Europa is an icy moon. And under its icy crust, we're pretty sure it has an ocean of water. I'm not sure how salty that water is going to be, but the fact that there's liquid water always raises that quick question. If there's water, is there life? Could there be life on Europa? It's a big question. Let's zoom back out. We'll look at Mercury in a different software in just a little bit. Let's look at Saturn real fast. Unfortunately, well, let's get rid of the atmosphere so we can see this a little bit better. Yikes. Guess not. Okay. Here we are looking at Saturn. Probably microbial, says Chet. Yeah, you're actually not wrong. It's likely, if there is life out there, it's likely going to be microbial. That's what we've been looking for on Mars. It's likely what we'll try to find on Europa. And actually, there is a moon around this beautiful planet Saturn that is called Enceladus. And Enceladus also seems to be one of these ice-crusted moons with liquid water under its surface. But interestingly, with Enceladus, there's actually geysers of water being shot out into space. Enceladus, if we zoom in here, and it's hanging out right up here. Oh god, why is Saturn drifting? Come back, friend. Saturn is my personal favorite planet. Don't at me. A lot of people love Jupiter. Saturn's my personal favorite. The rings, obviously, that's what sold me on it. When I first saw Saturn through a telescope, I went, oh my god, this is amazing. Changed my major. Went back to all my astronomy books that I've been collecting since I was a kid and was like, yep, I'm going to do this for the rest of my life. And that didn't happen for the rest of my life. But here we are. Nonetheless, we're going to try again. Saturn does have icy rings around it. There are other planets with rings. All 4 of the gas giants, Jupiter, Saturn, Uranus, and Neptune, they all have rings. Saturn's rings are the only ones we can actually see from the planet Earth. You do see some interesting structure to the planet's rings. This dark ring right here, this is called the Cassini division. It's actually a nice little gap in the rings. There's also what's called the Encke gap, conveniently named. It's a smaller gap way out here along the edges. Let's wait for the song. Hold on. I don't know why it does that, but there you go. Titan is the largest moon that orbits around the planet Saturn. It's hanging out way up here tonight. Interestingly, of all the moons in the solar system, Titan is the only one that has an atmosphere. Growling little dog, you are not helpful for this planetarium show. My goodness. Let's let the sun set. A little bit more. And as you see, this is not going to be visible all that long, because already the sun is gone. This is currently 6:15, and all the planets that we were just looking at, they're all gone. So you have a very short window tonight to see this conjunction in the western sky. Now we're going to go ahead and back out and look a little bit more towards the whole sky. Now this is an artificial sky. This is a sky with no atmosphere, or no light pollution, I should say. If you've ever been in a city, any major city, you know the sky doesn't look like this. And that is kind of the unfortunate thing with modern society. We're not as connected to the sky as we used to be. So what do I mean by that? Well, it is a concept called light pollution, and we'll look at that a little bit more in 3D in just a little bit. But if I may bring up a window here, so sorry to break the immersion. Watch the sky as I change the amount of light pollution. we're going to go ahead and add in some light pollution. Let's say we're in a much larger city like Tokyo or New York City or some, Dallas, Fort Worth, whatever large city you want to talk about. You'll notice all the stars seem to have disappeared. They're still there, but because we live in urban areas with lots of lights, that artificial light, since it's so much closer to us than these very distant stars, it blocks out. It kind of basically blinds us from the nighttime sky. Now, doesn't matter which culture you want to talk about. Every culture looked at the sky and came up with stories. These stories usually had to do with either heroes or great beasts, heroes of legend. You name it, there's different ones. Now, every culture had them. Officially, modern astronomy uses constellations, as we call them, that are from... Good God, little dog. That are from Greek, Roman, or Arab and Egyptian origin. If you were to be able to look at all the constellations in the nighttime sky tonight, connected by, lines, it would look like this. The sky would look vastly different, right? Dog disagrees. Serious. Grumpy puppy. Adding in shapes, there we go. The sky would look more like this. So you've got, a bull, you've got a dude with a club, you've got a horse, a unicorn, you've got a giant hydra snake, you got a bird, you got a fox, you got all these different things. But I thought it was just little points of light in the sky, right? Well, no. These are what we call constellations. Now, there are other shapes in the sky that are not official constellations. We call them asterisms. An asterism is either a group of stars that make a shape, such as a triangle or a hexagon of bright stars, something that kind of help you find your way around. The most obvious asterism is actually something that a lot of people know about. It's called the Big Dipper. We'll look at the Big Dipper here in just a little bit. But the Big Dipper, believe it or not, is not a constellation. It is a chunk of something much, much larger. So there is a difference between an asterism and a constellation. Just wanted to kind of get that out there. I also wanted to really quickly talk about the differences in the sky, depending on which culture you talk about. Again, these are Greek, Roman, Egyptian, and Arab-based constellations we usually use when we look at the sky. But there are so many different cultures on our planet that looked at the sky and saw very, very different things. Unfortunately, this is an incomplete representation, but this right here is the Navajo sky. I would love to learn more about the stories from the Navajo people. Here we have the same exact nighttime sky tonight, but this is with Chinese star lore. These are Chinese constellations. First Nations, or... Yep, there we go. I believe this one's labeled Inuit. There are First Nations up in Canada. Depending on where you want to look, this is the Sami. I believe they're over in Scandinavia and Finland. Here we go. There's only a couple of them. Some of these are incomplete, and that's kind of unfortunate. Every culture has their own version of the sky and their own stories. I would love to learn more so that I can teach other people. That's a dog licking my tongue. That's wonderful. Good Lord. He's not normally like this, but that's okay. So here we are, getting rid of all these constellations and coming back to our nighttime sky. Now, tonight and for the next, month and a half or so, the only planet you'll be able to see without the use of a telescope will be the planet Mars. Now, Mars is the red planet, as it's called. It is not all that easy to see through a telescope, to be honest, because it is much smaller than the other worlds that we've talked about so far. Jupiter and Saturn in particular. It's about half the size of Venus, about half the size of the Earth. Mars, through a telescope, is sometimes not all that impressive, but it does change color slightly. And the reason for that is actually on Mars, you do have a very thin carbon dioxide atmosphere, and occasionally you get windstorms. Huge dust clouds get lifted up and float around the atmosphere, so much so that the entire planet will get covered in dust. And instead of being red, Mars kind of turns like a pink color. We'll look closer at Mars when we go into 3D mode here in just a second. We do have an interesting crack right along the surface right here. This is Valles Marineris, Mariner Valley. If you were to look at a map of the planet Earth and put this huge crevice on the planet Earth, one side would be in San Francisco, the other side would be in New York City. It would cover the entire United States. At its deepest point, it is 5 times deeper than the Grand Canyon. Grand Canyon's a little bit under 2 kilometers deep. So this one's about 10 kilometers deep. Much, much deeper. There are ice caps on Mars, and there's actually seasons on Mars. It's tilted over, kind of like the Earth is. The Martian day, however, is slightly longer than an Earth day, and that's actually something that's always kind of interesting to talk about. If you think about it here, on Earth, it's 24-hour long day. On Mars, it's 24 hours and 37 minutes. And so a Martian day, what we call a sol, is slightly longer. So after about a week living on Mars, you're about 3.5 hours different from here on the Earth. That makes timekeeping a little bit harder. We'll be talking about Mars a lot in the next coming month or so. There is a Mars rover heading to Mars right now as we speak. It was launched in July, and it will be landing on the 18th of February. We'll be doing a live stream for that landing, and hopefully that will all go well. When we get there, let's back up a little bit. Let's look at these things in 3D. Now, really fast. Little dog, stop chewing on that. You will notice there is a nice flattened out line. The planets appear to travel along this plane in the sky. This is called the plane of the ecliptic. The other way of referring to it is the zodiac. The sun, the moon, and all the planets appear to travel very closely along this path. There are 12 zodiac constellations corresponding with the 12 months of the year. But the real question is, why? Why are they on this flattened out plane? For if you like pizza, friends, you already know why. You're probably wondering, what in the world are you talking about, crazy person? Well, let's switch to this. This is Universe Sandbox. Again, we got our sun in the middle here. The sun, a ball of plasma and gases. You'll notice there are convective zones bubbling up stuff to the surface, and then sucking it all back down into the star itself, giving off heat, fusing hydrogen into helium and other elements in its core. The closest planet to the sun, which we talked about already, was Mercury. There we go. There's the rocky world Mercury. There is no atmosphere on this planet, around this planet, and so you have this very interesting thing. If you are on the sun-facing side, you're going to be boiling. It's going to be like 400 or 500 degrees on the surface. If you're on the side facing away from the sun, you're freezing. Hundreds of degrees below zero. So your choice is either freeze or boil. Never fun. Very, very bright. What do we got in chat? Even so bright, even as a model. Yep, it's the sun looks very bright because we're very close to it. We'll actually see in just a little bit as we float away. The sun will get dimmer and dimmer and dimmer. We'll talk about star brightness in a second. Let's come in here and look at Venus. Again, Venus has an atmosphere made of carbon dioxide. Venus is an oddball planet. People like to call it the Earth's evil twin. Now, that's kind of true and kind of not true. It's about the size of the planet Earth. It's a little bit smaller, not much. That's really about where the comparison ends. Venus rotates differently. I won't say wrong, but it rotates differently. The sun rises in the east and sets in the west here on the Earth. On Venus, it rises in the west and sets in the east. So it's rotating opposite our planet. Also, its rotation is very slow. A day on Venus is almost as long as the entire year. which means the same side is usually facing the sun for a very, very long time as it slowly rotates around. That atmosphere traps in a huge amount of heat. Very few probes have landed on Venus. Soviet Venera landers, for example. They didn't last very long. I would love to study this planet more. Venus was in the news last year for a little while because there was an interesting discovery where they discovered kind of biosignatures, biomarkers in the upper atmosphere, which would indicate some sort of microbial life in the upper atmosphere, and then that kind of all went by the wayside, so either they're still studying it or they decided that was not true. So we'll see whatever happens with that. Let's zoom out a little bit and talk about the planet Earth. Except that's moving a little bit too fast, ain't it? Let's slow that down. Now, when we talk about the Earth, I always like to talk about the Earth at night. As you see, we talked about looking at the sky and how there's light pollution. Let's slow this down a lot. You can actually pick out major cities. There's Tokyo, there's Seoul, there's Beijing and Shanghai. You can see large cities based on... Oh, there's the beautiful Nile River. And you can see Cairo. There's Rome, Paris, London, Madrid, Barcelona. Looks like Moscow back there. There's the eastern seaboard of the United States, New York, Philadelphia, Washington, D.C. You can pick out major cities. Wherever you see brightness on this is not where you want to be to look at the sky. You want to be where it's much darker. So, out west, as you can see. Beautiful Hawaii. Lots of great observatories there. Oddly, North Korea would be a great place to do observing, but I would never want to visit. There's no light there. Afghanistan. Yeah. Earth is a very strange and fragile place. We should probably take care of her. Let's see, where are we? Mercury, Venus, Earth. We should probably round out with Mars, right? So, let's go to Mars. Now, with Mars, this is the final of the, what we call terrestrial or Earth-like planets. Terra meaning Earth-like, so these are the small rocky worlds, somewhat close to the sun itself. Here's a good look at Mars. There is an area of Mars called Tharsis, which should be coming up in just a couple seconds. That's where there are 3 shield volcanoes and a very large volcano called Olympus Mons, or Mount Olympus. If you look at the map of the United States and you see the Four Corners region, Arizona, New Mexico, Colorado, and Utah, this volcano would fill up any of those states, the entire state. There's Valles Marineris, there's Mariner Valley, there's Tharsis coming up, the 3 shield volcanoes, and Olympus Mons. This is as big as Arizona, or Utah, or Colorado, or the state of New Mexico. The entire state. One single volcano. Interestingly enough, it is opposite a huge former crater. It's actually, you'll see it coming up here in just a second. There we go. Mars is really interesting. It's not a living planet, so to speak. It doesn't have lava like it probably used to long ago. It doesn't have cracks on its surface, making plates like we have here on the Earth. That's what causes earthquakes here on the Earth, plate tectonics. That doesn't happen with Mars. But it doesn't mean it's totally dead. We're not really sure, but there seems to have been water on Mars. There's lots of crevices and, lots of formations that appear as though they may have been, lake beds or rivers flowing in and out of craters. In just a few weeks, we're going to have another rover on, hopefully, surviving its landing and roving around a crater called Jezero Crater, which is near the equator of the planet. Like, right here, look at this. That looks like a river, doesn't it? Leading into a crater. If there was water on Mars, was there life on Mars in the past? If there was water on Mars, is there still liquid water under the surface of the planet? That's a huge question that we're still trying to answer. Now, after you pass Mars, there's what's called the asteroid belt. Some of them are large enough to have names like Ceres and Vesta. They are chunks of rock that are floating around the sun. Let's take a look at Ceres real fast. You can see it kind of looks like a little mini planet, right? But it's an asteroid. So there's minor planets, the asteroids and things like that. There's planets, the inner planets, the terrestrial planets, the outer planets, the gas giants. And then as you get out further, you have what are called dwarf planets. Trans-Neptunian objects that are out there. I believe Ceres and Vesta are actually considered dwarf planets as well. We'll get to them in just a little bit. There's a look at Jupiter. Great red spot kind of comes and goes. There we go. As it rotates around every 8.5 hours or so. The only thing I don't like about this 3D model is that Saturn, for whatever reason, doesn't have rings, and it just looks really bizarre. There's Saturn with no rings. Don't ask me why the rings aren't there. I have tried. I don't know why they don't show up. So we're not going to look at them. We're going to zoom back out. Out past Saturn, you have what is called the planet Uranus. Not Uranus, it's Uranus. Zoom in. Much like Venus, we're not really sure what's going on with Uranus. Uranus is tilted over. And the best way to describe that is that you're not looking at the North Pole up here. The North Pole is here in the middle. And the South Pole is back here. So half the year for Uranus, the North Pole faces the sun. Half the year, the South Pole faces the sun. The entire system, all the moons, everything tilted over onto its side. And we have no idea why. It's one of the mysteries of our solar system. The last one we're going to talk about, Neptune, the other gas giant way out here, blue-colored, hence the name Neptune, named after Poseidon, or Neptune, the god of the sea, in Greek or Roman mythology. Neptune, hypothetically, is shrinking slightly. There's actually a lot more heat in its atmosphere than was previously assumed. There's actually cloud structures, and there's even a spot called the Great Dark Spot. It's kind of like the red spot from Jupiter, but it's dark. And we don't know why it's even there. It shouldn't be there, but it is. Kind of an interesting thing. So there's a look at our solar system. As we zoom out, you'll notice all the planets appear to be on a flattened out plane. You'll notice they're all nice and squat. So think about pizza. I mentioned pizza earlier, right? When you do hand-tossed pizza, you start out with a ball of dough, and as it spins around, why did all my little lines go away? Let's get those back, shall we? The planet orbits are gone. There we go. As you rotate your pizza dough, you get a nice flattened out plane. Well, that's kind of the same idea. The planets are all along a nice flat plane orbiting around the sun. These outer planets do not follow that. And obviously Pluto is one of these wonky these minor planets, these dwarf planets, way out at the edge of the solar system that doesn't follow the rest of the planets along the ecliptic, as it's called. Oddly enough, the same kind of idea happens with the galaxy. Way in the background, you see the Milky Way. It looks like a flattened out plane. There's a big bulge right there. That's what we see in the summertime months. We look towards the heart of the galaxy. During the winter months, like we are now, we look out towards this part of the Milky Way galaxy. And as we mentioned earlier, as we zoom out further, you notice the sun is getting dimmer and dimmer and dimmer. Some stars are intrinsically bright because they're just really bright stars. Other stars are bright because they're close to us, or in this case, the sun is close to us. What do we got in chat? Neptune is still one of the prettiest planets. It is! It does have rings, and it's really, really pretty. We just don't know too much about it. It's really hard to get to. It's far out. Far out, man. It's really far out in the solar system, and it does take a very long time to get probes there, and for whatever reason, we do study Jupiter and Saturn far more than any of the other outer planets. Why we don't really have an orbiter around Uranus or Neptune, I don't know why. We just seem to find Jupiter and Saturn to be much more intriguing. I really need to put this puppy somewhere else so I can finish this show. Serious, come on, dude. All right. Just pick them up. Try this again. So there's our solar system. And that is why there's a nice flattened out plane that all the planets appear to travel from our point of view. Let's get back to our planetarium. Maybe. There we go. So that is why all the planets appear to be on this flattened out plane. There we go. There's the line. That's why Mars will be sitting there, and why all the planets will be along this line, what we call the zodiac, or the plane of the ecliptic. Now, let's talk about the rest of the sky, shall we? We've been spending all this time talking about planets. Let's talk about some constellations and some asterisms, and use these points of light to find our way around. We're going to start out looking towards the north. Now, looking north, again, this all depends on where you live, because the further north you are from the equator, the higher up these stars are going to be in the sky. I'll show you that in just a second. Also, if you're the reverse of that is true, if you're closer to the equator, some of these stars might not be visible to you at all. So, pay attention to where you live, look at a globe, look at a map, and then go out and look at the sky and kind of match it up. Let's take a look at some constellations in and around the North Star. In fact, let's find the North Star. To find the North Star, you can use an asterism called the Big Dipper, or you can use a constellation called Cassiopeia. Now, the Big Dipper is kind of low in the sky up until around 8:30 or 9 o'clock at night. Cassiopeia is nice and high in the sky. That's actually the way it always is. These two are opposite of each other. Cassiopeia is a 3 or a W shape. You're going to see me drawing a little triangle out up here and another triangle. It's way up here. Equal-sided triangle and then a squishy triangle. Let's go ahead and put the constellations back up. So there's Cassiopeia, the queen, very vain, sitting on her throne, looking at herself in the mirror. Kind of an unpleasant queen in stories, at least. Opposite of her in the sky, you find Ursa Major, the big bear. The stomach and tail of this bear are the Big Dipper. And they are always opposite of each other. So if the Big Dipper is low, Cassiopeia is high in the sky. If the Big Dipper is in the eastern sky, Cassiopeia is in the west. If Cassiopeia is low in the sky, the Big Dipper will be high. They are always opposite of each other. So it's really helpful to be able to find either one of these, preferably both, because they will help you find the North Star, Polaris, the Pole Star, also known as the Lodestar. So how do we do that? Well, let's start out with Cassiopeia. Remember that equal-sided triangle that we just made a couple seconds ago? Right up here. This triangle, if you draw a line through the open side, will take you to a star. Now, it's not the brightest thing in the sky, but this is the North Star, the Pole Star, the Lodestar. How do we know that? Well, we need to use the Big Dipper. And again, Big Dipper may or may not be up for you, so it depends on where you live. The Big Dipper is made of 3 stars in the tail and 4 stars. It's going to be over here. 1, 2, 3, and 4. These last 2 stars that I've left the line in, we call them the pointer stars, for they will point you to Polaris. That's the exact same star we just found using Cassiopeia. So you can use this side over here, or these 2 stars, draw a line through them. Either way, you end up in the exact same place. This is Polaris, the Pole Star, the North Star. As you watch, you will see stars will rise and set, but the North Star basically sits in the same exact part of the sky. Now, from where I am observing from, the North Star is about 35 degrees above the horizon. If you live somewhere else, let's get rid of the atmosphere, that's really bright. If you live somewhere else, the North Star will be a different altitude above the horizon. So for here, it's about 35, 36 degrees. You live in, let's say, Toronto. That's the wrong button. Yikes. Let's try that, Toronto. Let's go north. Toronto, Canada. Let's go there. Now, you'll see that the North Star seems to be higher up, doesn't it? Must apologize. I'm doing this one-handed because the puppy is now in my hand. He has stopped growling, which is great. Here we are in Toronto, and it's now 43 degrees above the horizon, so much higher up in the sky compared to before. There we go. Let's come back to where we were a little while ago. Reset location list. Reset to default. There we go. All right. So we found the North Star. We found Polaris, the Pole Star, the Lodestar, North Star, whatever you want to call it. This has not always been the North Star. Now, this star right here in the constellation Draco, the Dragon. This used to be the North Star. That is Thuban. The Earth kind of wobbles like a top. And at least in the current epoch, it seems to be pointing towards Polaris. But many, many, many years ago, it's actually pointing towards this star. So there are times where it actually processes through the sky. I believe that's a 26,000 year cycle for this to happen. You see again the Big Dipper and Ursa Major hanging out down here. Again, Big Dipper is an asterism, not a constellation. The Little Dipper, however, is the entire constellation, the Little Bear. Why this bear has a tail, well, that's related to the story, but we're not going to get into that because we would be here all day talking about every single one of these constellation stories. That's what you can find in the northern part of the sky. Now, it's going to get really bright for a second. Actually, it won't, because I got rid of the atmosphere. Let's let the sun set. Let's look towards the south. This is what I really love to teach, is finding your way around the winter sky. Because it's so easy to do. The winter sky is full of bright stars. In particular, the winter sky has likely the most famous of constellations. Now, this constellation has many different stories related to it. Some are more unpleasant than others. But this constellation is the constellation called Orion. It is the Great Hunter. Orion rises up right at sunset in the eastern sky. So if you're outside around 6:30, 7 o'clock, you're going to see Orion in the sky. There are 3 stars, an asterism called Orion's Belt. 3 stars in a line, making his belt. It's right here. You can't miss them. They're all fairly bright. They each have their own names. Their names don't really matter. They're Alnitak, Alnilam, and Mintaka, but their names don't matter, but they do have names. 3 stars of the belt. His shoulder star is a red giant star named Betelgeuse, or Betelgeuse, I've heard it pronounced as well, but I believe it's Betelgeuse. It's a red giant star, a star nearing the end of its lifetime. And it kind of glows a golden reddish color. His knee star is a blue star named Rigel. So you can see again the color differences between stars all in this one particular constellation. And you can see multiple other constellations if you use this as your guide. And what do I mean by that? Well, let's begin, shall we? Orion the Great Hunter in some stories is carrying an unbreakable club and a lion's pelt. Other stories he's carrying a sword and a shield, and he might be fighting a bull. That bull is Taurus, the bull of the zodiac Taurus constellation. Now, to find it, you just need to draw a line through the belt. Draw a line through the belt away from the horizon, and you end up here. This is a V of stars known as the Hyades. This is the face of Taurus the bull. This is a open star cluster, a group of stars that are all sort of loosely related to each other. Let's bring up the constellation. Come on, there it goes. Bright red star, the eye of the bull, named Aldebaran. Visible pretty easily. Along the back of Taurus the bull ride 7 beautiful maidens, the 7 sisters, the Pleiades. Alcyone, Electra, Merope, Asterope, Taygeta. These are all some of the stars of the Pleiades, and if you zoom in, even with a set of binoculars, you can see this little beautiful cluster of stars. And if you were paying attention earlier, we did say that we have a cat named Alcyone. That is her star right there. It's in the Pleiades. She is a Pleiad. Let's come back to Orion. What else can we do with Orion? Well, we can find a set of twins. Also, zodiac constellation. The Gemini twins, Castor and Pollux. How do you find them? Well, remember I said he had a knee star named Rigel? Start with oh god. No, what happened? Where'd my sky go? Ah! It's not what I wanted. Let's try that again. I apologize. Instead of clicking the time forward, I click the time reset. Don't mess with time. Time is a terrible thing to waste. Also embarrassing when you do stuff like that. Start with his knee star. This is Rigel. We're going to go from Rigel through the belt to Betelgeuse. And then keep going. But we don't end up anywhere, do we? Oh, yes and no. You're going to end up kind of near these two parallel stars. That's where you really want to be. I guess you could draw the line more like this if you really wanted to, but you don't end up drawing them through the stars. These are the Gemini twins, Castor and Pollux. They are some of these constellations I've never heard before. Yeah, there's 88 of them. They're not all visible in the north, and honestly, some of them are really hard to see. Like Cancer the Crab is a zodiac constellation. It's really hard to see, to be totally honest. There's also Monoceros, which is this unicorn shape that's hanging out over here, but really, it's really, really hard to see. Even in a dark place, you're not really going to see it. So we found the Castor and Pollux. Those are the Gemini twins. So we found, let's see, Taurus, that's one constellation. We found Gemini, that's another constellation. What else can we find with Orion? Well, let's use Orion's belt once again. Draw a line through the belt of Orion. That is the last line I drew. There we go. There's the belt. Keep drawing a line down. Now, if you're outside around, 9 o'clock or so, you're going to see this really bright star appear. And because it's low on the horizon, it's going to be rapidly scintillating. Scintillation is the scientific word for twinkling. It's going to be twinkling really, really, really rapidly. Huge amount of color shifting because the atmosphere is really thick along the horizon from our point of view. There's a lot of light bouncing off really thick atmosphere. When stuff is really high in the sky, there's less atmosphere to look through, so it doesn't twinkle as much. But around 9 o'clock, you will see this bright, very bright star. So bright, in fact, it is the brightest star that you can see at night. Seriously, it's really bright. It is the star Sirius. Now, it is also called the Dog Star because it's in the constellation Canis Major, the big dog. It's either the, something on his collar or it's his heart, whatever you want to call it. One of Orion's hunting dogs in some stories, Canis Major. Now, there is a smaller hunting dog named Canis Minor, made of 2 stars. So it's a hot dog, or a dachshund, if you want to call it that. That star, of those 2 stars, is named Procyon, that bright star. Now, these 3 stars that I have just mentioned make an asterism that you only see in the winter months. Let's point it out and then talk about that real fast. So let's start out, I guess we'll start with Sirius, since that's what we were drawing a line to. We have Sirius. We have Betelgeuse, which we talked about before. That's usually where I like to start, is start with Betelgeuse, because that's in Orion. Draw a line to Sirius, and then you draw a line this way. You find Procyon. Now, the other way of finding Procyon is draw a line between Sirius and Betelgeuse. Split it down the middle. You find Procyon. This is a triangle, 3 points of light. This is a triangle. This is called the winter triangle. You only see it during the winter months, and you have connected 3 different constellations: Orion, Canis Major, and Canis Minor, the little dog. Look at that, you just found 1, 2, 3, 4, 5 constellations, all by looking at one part of the sky. Convenient. Now, as I mentioned, there are some other constellations like Lepus, the Hare, and Monoceros, it's a unicorn. But they're really hard to see. Lepus, not so much. It's not so hard. You can kind of see Lepus below Orion. But to find it, you would just draw a line through the belt and keep going down. You find this little rhombus of stars down here, and that's part of it. And then you got the little bunny ears heading up this way. But again, it's really hard to see. We're going to stick with Orion real fast, because I want to mention a beautiful little nursery. Have you ever seen an area of baby stars? Cute little babies. You can see, even without a telescope, an area that will one day be filled with stars. Find the belt of Orion. The 3 stars in the belt once again. Alnitak, Alnilam, and Mintaka. The middle star, Alnilam. Just below it. I'll actually zoom out so you can see. Just draw a line straight down from that middle star. And you're going to see, even without a telescope, with a set of binoculars, you see a little fuzzball. With a telescope, you will zoom in and see this. This is a stellar nursery. This is called the Orion Nebula. Now I want you, if you have the ability to put your hands together as if you're trying to cup water coming from the sky or from a fountain. Put your thumbs together, put your pinkies together if you can, and you're making like a U shape, right? A cup shape. That is the kind of shape that we're looking at. We're looking at it from the side. This is actually kind of like a little cocoon, and inside of it, right in here, there's what's called the trapezium. There's 4 stars in a trapezoidal shape, and they are heating up. They are illuminating. They are causing this entire cloud to glow like a neon bulb. This area will one day be filled with baby stars. Of course, once they become stars, they're no longer babies, they're full grown. But right now, this is a star-forming region. Orion's chock full of interesting stuff. Just above it, you see a constellation that's oftentimes called the Running Man. Looks like a guy. This right here. It's a guy jumping over a star. Does it really look like that? I don't know. It's just what they call it. During Halloween, sometimes you'd like to talk about what's called the Witch's Head Nebula. Well, it's a winter constellation related thing. It's over here. It looks like a witch's head, cackling witch in the sky. Orion, chock full of stuff. You ever heard of the Horse Head Nebula? The Horse's Head actually is right below Alnitak, which is the leftmost star of the belt. There it is. We have zoomed in. This one little region has 3 different types of nebulae. Nebulas, whatever you want to call them. You got a reflection nebula, kind of like what we saw around the Pleiades. You got this blue-colored star, blue-colored cloud, I should say. It's got light deflecting through it, refracting through it, kind of like our own atmosphere turning blue. That's what's going on here. Then you've got the glow of this red over here, and the Horse's Head kind of looks like a scorpion tail, to be honest. But people call it the Horse's Head Nebula. Well, again, that reddish glow, that's actually the gas itself glowing in space. Meanwhile, you have a dark, cold nebula over here, but inside, you'll notice there's actually light filtering through it. There's dust and gases that aren't illuminated right in here, but inside of here, stars are also being formed, much like the Orion Nebula. And that's just this one part of the sky. We're ignoring this huge trail of red color here. You don't normally see that. We see it because it's our little planetarium dome. There's a huge area of star-forming occurrences. And this is because it's along the outer portion of the Milky Way. We haven't really talked about it. But the Milky Way is our galaxy. Let's shift gears real fast. We've been talking about planets. We've been talking about stars and kind of what we see from our planet. But you have to think big picture. Our star, the sun, is what is called a yellow dwarf star. It is not all that big, and it's not all that bright, to be totally honest. It is one of many, many, many stars in what is called the Milky Way galaxy. Now, the galaxy is a collection of millions and millions of stars, billions of planets. They come in different shapes. Some of them are called elliptical galaxies because they're kind of like a football-shaped galaxy. Other ones are called spiral galaxies because they look like a big pinwheel. And then there's what are called irregular galaxies. They don't really fit in either of those two categories, sometimes because they just haven't formed properly yet, or they're actually the result of galactic collisions. We'll talk about that kind of stuff here in just a little bit. Let's go back to our 3D software. Let's talk about some of these concepts that I just talked about. I said the sun is not all that big, so here's the sun in our solar system. Let's change things up real fast. Remember, we just talked about Betelgeuse, and I said it was a red giant star? I wasn't kidding. Look at the size of Betelgeuse compared to the sun. If we were to bring Betelgeuse and place it here in our solar system, well, I exploded us. That's not what I wanted. I've made a mistake. This is why you shouldn't play God. Let's bring this back. Let's put Betelgeuse somewhere up here instead. I want you to see how huge Betelgeuse is. Oh dear. Oh, Neptune. Betelgeuse itself would take up... I just did it again. Betelgeuse itself would take up the inner solar system, so everything from the sun all the way out to Mars would be taken up by one single star. Can I just get a blank? Is that a thing? Empty. That's good. Here we go. There will be no explosions here. I apologize. Let's do this. Here's the sun. Okay. Here is Betelgeuse compared to the sun. Our solar system would be over here. Look at Betelgeuse. That's what happens when a star gets old. Stars, when they begin to age, they start fusing different amounts of different elements in their core, and they start producing less and less energy. They actually start getting colder. They turn red. Now, there are some exceptions. There are some small, young blue stars. We're going to go ahead and put a bunch of other ones in. Some that we haven't talked about, such as Vega and Spica. These are summer stars. You can see young, hot blue stars. They do have a very distinct glow to them. There's Spica, very blue. And we got Vega over here, which is kind of more of a white-colored star. There we go. You can see they do have similar structure. They have the little convection zones and things like that. But very different when you get to something like a red giant. Red giant stars are going to explode one way or another. Let's see here. Where's my little thing? Let's add some more stars in here for comparison's sake. We talked about Rigel. We put that in there. We talked about Procyon. Let's put that in there. Procyon's kind of like our sun. Not all that big. Again, these are nowhere near each other. We're doing this just for science. Let's look at Antares, another huge red giant star. Stars that are nearing the end of their lifetime, they will actually puff up and become red giants. Now, depending on what they were when they were a regular star, what we call a main sequence star, they could either puff out and leave behind a nebula, what we call a planetary nebula, big round cloud in space, or they can explode violently. And if they explode violently, they make what is called a supernova, or a supernova remnant, is what we call them today. There actually is one of those out tonight. Come on. Let's get back to our planetarium. It's jumping around real fast. I apologize. We're kind of being scatterbrained here. But, I did want to mention this real fast. A good example of that is actually in the the horn of Taurus the Bull. It's up here. This is what happens when a star explodes violently. This is a supernova remnant. It's not very calm looking, is it? This is actually where a star has exploded. This was actually seen way back, I believe, in the year 1054. That number sticks out in my mind. Chinese astronomers saw an object in the sky in the daytime and the nighttime, and it was there, and then it was gone. And then no one knew what it was, and so no one realized that it was actually the same object till years and years and years later. This is actually the leftover from a star that has exploded. In explosions like that, you get heavier elements. So hydrogen turns into helium, and then helium turns into lithium and carbon and nitrogen and oxygen. So you get, stuff that we're breathing in right now. But you get all the different elements of the table of the periodic table of elements, all the way up to iron. When you get to an iron core, the star will start to collapse. It might explode violently, or it may just leave behind a hot core called a white dwarf. Just depends. But I want you to think about that really fast. I mentioned iron. When you breathe in oxygen and nitrogen and other stuff. And the oxygen combines with something in your blood called hemoglobin. Your blood turns red when it gets oxygenated. There's iron in your blood. You are stardust, friends. It's always hard to think about. We're all just dust from a star. How that all happened, that's all up, I guess, to you. I'm just here to talk about the scientific side of things. At least how we understand it. So there's all these different stars. It's like a waiting existential crisis. It kind of is. We have all these different kinds of stars. We looked at young blue stars. We looked at red giant stars in this little simulation here. And let's talk about something else. Let's talk about what's in the background here. This Milky Way. This is the whole reason we were out here, right? Our Milky Way is a collection of stars and gas and dust. It likely looks something like this. Now, it's sped up. It doesn't move this fast. But all the stars are in orbit around a black hole, an area of space that not even light can escape. And that's in the core, a supermassive black hole. Kind of like the sun is at the center of our solar system, this supermassive black hole is at the middle of our galaxy. Our galaxy likely looks like this. There are subsets of spiral galaxies that are called barred spiral galaxies, where there's actually like a weird horizontal bar going through the middle of them. This is more of a pinwheel style spiral galaxy. And so you have older red colored stars living near the core and the younger blue stars out towards the edges. Now, these gaps we always thought were empty. Maybe where dark matter is. We're not really sure what's going on in the arms of spirals, because they all seem to be moving at the same rate of speed out here. As you go out further and further, you do go slower, but these arms kind of move at the same speed, and we don't know why. Our sun is just one simple star out along one of these edges. When you look at our galaxy from the edge, like this, you see stars going in and out of the plane of the galaxy. Again, remember the pizza analogy. But from our point of view, this is how we see our Milky Way. So that means we are along the outer edge, and we're likely all over on our sides. Because what is up or down when you're in three-dimensional space? Or in this case, four-dimensional space, because time matters. Time dilates as you approach the speed of light. When you get to distances like this, you have to use the speed of light as a measurement. To get from the sun to the Earth, it's only 8.4 light minutes. It takes light 8.4 minutes to get from the sun to the Earth. That's 93 million miles, or 150-odd million kilometers. 2 hours to cross our entire solar system, give or take. Thousands of light years between different sections of our Milky Way. But when you look at it this way, If they don't all do this, our sun happens to be alone. Our star is alone. Some stars are in binary units, so there's two stars orbiting around each other. Some of them are in trinary units, where there's two small stars and a bigger star, that they all kind of orbit around each other. Maybe no solar systems in those, no planets. But I want you to think. Let's just start throwing out some numbers. Let's say there's 100 million stars in the Milky Way. There's not, but let's just use that because it's an easy number. If 100 million stars existed here in this exact screen, and each one had 8 planets, how many planets are there? And if one of those 8 had life, like our Earth does here in our own solar system, how many planets have life? Just in that example. But our Earth is kind of special. We happen to be the right distance away from the right kind of star that we don't get burned up. We have liquid water, and our life is liquid water-based and carbon-based. Are there other types of life out there? Can lithium be a basis instead of carbon? Do you really need water? Are there other stars that have planets with water around them? Probably. Now, think big picture again. Think about your home address. Whether you live in an apartment or a home, or whatever it is, you start off with the building number, and then your street, and then maybe your apartment number, and then you have your city and your county and your state or prefecture or whatever, however your country happens to do it. And then you have your country code and your zip code. And then you can end that with planet Earth. So you're in, for example, for me, it'd be the city of Rio Rancho, and then you have New Mexico, the state, United States, the country, and then planet Earth, my planet. Solar system, that's the next step out. After solar system, you then talk galaxy. So after solar system, you say Milky Way. But it doesn't stop here. The Milky Way, which is our galaxy, is actually part of a little family called the Local Group, which I don't see, so I'm going to type it. The Local Group is actually a little grouping of galaxies that all kind of hang out. So here we are, zooming out a little bit more. Here's the Milky Way once again, looking a little bit different though, because we got to have all these other things loaded up. Look at all these other galaxies. There's the Sagittarius Dwarf Galaxy. There's the Draco Dwarf Galaxy. So these are small little satellites. Just like the Earth has the moon, the Milky Way has these little galaxies hanging out nearby. If you live in Australia or New Zealand or anywhere south of the equator, you might actually see the Magellanic Clouds in the sky. The Magellanic Clouds are named for Magellan, which is kind of junk because they were known by Aborigines and other people that lived in the southern part of the planet before Magellan, but they named them after him, so whatever. They are the Magellanic Clouds. They are little chunks of galaxies that hang out below the Milky Way. They likely were another galaxy that got torn apart by the Milky Way, consumed, as galaxies tend to do. Let's come back to the Milky Way. Now, the Milky Way is not the biggest in the Local Group. That title belongs to Andromeda. The Andromeda Galaxy is visible tonight. We'll go back and look at how to find it in just a second. The Andromeda Galaxy is about 2.25 million light years away. So at the speed of light, 3.0 times 10 to the 8 meters per second. At the speed of light, it'll take 2.25 million years to get there. It's way up there. But it's coming closer. Let's traverse to the Andromeda Galaxy. The Andromeda Galaxy and the Milky Way are the two largest galaxies in the Local Group. Because of that, their gravity is much larger than any of the other galaxies nearby. However, Andromeda is the bigger of the two. It has more gravity, and over time, this will likely happen. This is a simulation of the Andromeda Galaxy and the Milky Way going through this beautiful dance. A tragic dance, because neither will survive. The Milky Way and the Andromeda Galaxy are on a collision course, and they will eventually merge. The cores of the two galaxies will spin around each other and dance around for thousands and thousands of years right in here. Lag! Particle physics! Dynamics! What used to be two beautiful spirals is now just a big conglomeration of stuff. Some stars will collide. Most won't. Some planets and stars will get thrown out into the great unknown. The galactic voids, the huge voids between galactic clusters. Eventually, over time, these will settle down and maybe recoalesce into a spiral, maybe not. The local group is just a portion of what is called the Virgo cluster. So it's an even larger cluster of galaxies. And then that cluster is part of what's called the Virgo supercluster. And that's just one cluster in what we call the known universe. Billions of stars, billions of galaxies, meaning trillions and trillions of planets. And yet there's just one of you. And one of me. Unless you had an identical twin, then there's kind of two of you, sort of. To find the Andromeda Galaxy, we must look north once again. Remember we found Cassiopeia earlier. Well, she's up here, this W shape, this M shape, this 3 shape, whatever you want to call it. Nearby, you will find another asterism, what is called the Great Square of Pegasus. It is a square of stars, because when you think of horses, you think of squares. I know I do. That's the Great Square of Pegasus. Along Pegasus's leg, you will find an A-shaped constellation. Going in this direction. 1, 2, 3. Making kind of an A shape like that. You know you're looking in the right place because you can find the same thing by using Cassiopeia. Make the triangle, but instead of going through the empty end to the North Star, go from the tip and try to go towards that A. 1, 2, 3. 1, 2, 3. Either way, you are going to find the exact same thing. What used to be called the Andromeda Nebula, when technology advanced and people were able to take pictures of the sky. It's the Andromeda Galaxy. When you look at it through a telescope, it's going to look like a fuzzball. It's not going to look like this. So be aware. It won't look like a spiral. But this is it. This is the Andromeda Galaxy. This is the fate of our Milky Way. To one day kiss this other beautiful spiral. And dance for a very, very long time. Millions of stars, millions of planets. There's only one of you. Made of stardust. Unlike cats, we only have one life. Please make good use of it. Whether it's teaching, whether it's art, whether it's writing, whatever it is, do what you do to the fullest. Give it 100%. The only one that can stop you is you. The world's gone a little crazy. Keep yourself safe, take care of yourself, take care of your family, your chosen family, whatever it happens to be. But we're only here for a short time. Life is short. Learn as much as you can, teach others, find joy. My joy is in astronomy. Whatever your joy is, find it. Keep it. Hold it. Through astronomy, I've learned math, I've learned sciences, chemistry. If you like biology, there's a field called astrobiology. You like math? There's plenty of math in astrophysics. You like architecture? People want to travel to the moon and live on Moon and Mars. They're going to need architects to help design stuff. You like writing stories? Isaac Asimov is just one of many, many, many names, inspired by astronomy and science, what we now call science fiction. You like history? History of astronomy. Astronomy is one of the oldest, if not the oldest, profession. Of course, back then it was used for divination, what is called astrology. Astrology still exists today for some. It is a separate branch. Astronomy and astrology are two different things. I've been called an astrologer before. I am not Walter. I am not that special, that's for sure. But use astronomy as a stepping stone. You know, write a song, write a book, write a story, create a character, create a moon princess, like my little moon princess. Whatever it is, use it as an inspiration. Just go sit outside and look at the stars. You don't need a telescope. If you have a cell phone, which majority of people are, maybe you have a laptop. If you have a laptop, download Stellarium. That's what we're looking at right now. If you have a cell phone, I believe Apple phones, they have their own sky map. Google has their own sky map. Use it to help you find your way around. If you don't get this stuff at first, it's okay. Come back and watch another show. I do this every Monday and Wednesday. Friday we talk about current events instead of planetarium stuff, but we can as well if you want, if that's what chat wants. That's such a sweet message. Yes, I know, I try. Life's hard. Don't make it harder on other people. But it's one of those things where astronomy can lead you to lots of other little rabbit holes. You can learn a lot about science, but you can also learn a lot about yourself. You can learn about other cultures. That's the thing that I really want to do. Before the shutdown of everything, I had this grandiose idea of traveling around and doing astronomy in different places, visiting different observatories, talking about, how they were made and, what they do, what they look at, because there's lots of different things. What do I mean by that? Well, when you think of a telescope, you probably think of one of those things that you point up at the sky and you look through it. But there's more than just that. There are radio observatories, like the now deceased Arecibo Observatory, which I also got to visit. There's a very large array here in New Mexico. They look for radio waves. That is a form of light. You can do astronomy with it. It teaches you something that we can't see with our eyes. Above our atmosphere, you have things like the Chandrasekhar Observatory. They look for X-rays. X-rays like you get at the hospital? Yeah, same kinds, except emanating from stars, and from exploded stars in particular. Gamma rays coming out of really, really, really exploded stars. Ultraviolet light. The Hubble Space Telescope sees kind of what we can see with our own eyes, visible light. There's different light spectrums. The entire sky looks completely different when you look at it through different eyes. Just like the sky looks different when you look at it through different cultures. I could sit here and teach you all about these different Egyptian or Arab or Greek or Roman constellations, but that's a disservice to Native American populations. That's a disservice to First Nations. It's a disservice to Aboriginal. There's so many different sky stories. That's the stuff I want to learn. I've learned a lot of the science, but I want to learn some of the more fun stuff. really quickly, let's take a quick peek at the southern sky. To do that, we're going to go to... If I could spell it right, we're going to go to Sydney, Australia. Now, it's winter in the northern hemisphere, so it's summer in the southern hemisphere. So the days are a little bit longer, so I got to actually get rid of the sun. Here we go. This is a sky that I do not recognize. Orion's in the sky tonight if you're in Australia, but a majority of this stuff, I have no idea. These are constellations I have never seen, because I've never been to the southern hemisphere. Cetus, Reticulum, Hydrus, Triangulum Australis. I've never seen any of these things. Vela. I don't know about these things. These are other constellations. I'm sure they have their own stories. And I would love to experience them. Be taught them by other people. As I mentioned when we were floating around in 3D space, there are two galaxies. You can see them in the southern hemisphere. Here's the Milky Way hanging out over here. And below our galaxy, you find the small... There's the small one. And the large Magellanic Cloud. Again, these are galaxies, but they don't look like a spiral, right? They're just like a big pile of stuff. Star-forming regions over here. Why? These things exist. So many questions, so many things to learn. So many things to write about, so many things to create. But only so many hours in the day. And some of you, I haven't been keeping track, I keep seeing the number kind of fluctuate out of the corner of my eye. Some of you have chosen to spend some of your valuable time with me. And that's greatly appreciated. I hope you learned something. Maybe some of this you've heard before. The unfortunate thing about doing this style of show the way I'm doing it is, you know, I do it Monday and Wednesday. The sky doesn't really change much in 2 days. So I'll be covering a lot of the same things. But maybe in a different way. To watch astronomy in motion, so to speak, it takes time. And so you must have patience, and that's something that we have lost over time. We are used to everything being instantly on our phones or instantly on our computers, instant gratification. Slow down. Breathe in. Just sit outside. Safely. Be dressed for the occasion. If it's wintertime, dress up in warm clothes. Stare out your window, go to the nearby park, whatever it is, your own backyard. Safely stare at the sky. Even if you don't know what you're looking at. Just let your mind wander. If you want to know more about the sky, you can always come back and ask questions. I don't mind being interrupted. At least you can do that in here. In a planetarium, it's really hard to do that. Because in a planetarium, it's dark, and I can't see anybody. Here, it's a dark screen, hopefully. Hopefully you're viewing this in a dark room or in a screen that you got close to your face. But there's a chat window. You can just type in chat whenever you want. And we can talk about whatever you want. No subject is wrong, not even offbeat subjects like aliens and UFOs and stuff like that. It's okay. That's all part of this. The search for extraterrestrial life, SETI. Like, are we alone? I don't know. Have we been visited before by aliens? I can't tell you that, because I don't know. All I know is that when you look up, you see a lot of points of light. Some of them are close, some of them are far away. Each of them with their own story, just like you or me. Each unique little snowflakes. But we're all part of the same universe. A huge universe. Unfathomably huge. Hard to understand. Hard to wrap your brain around it. The one thing I always like to tell people that you can go out and do, you do have to be at least 4 years old to do it. Not because it's an age-restricted thing, but because of what we're going to talk about. When you look up at the sky, you're also looking back in time. And that's a concept that takes a little bit to understand. Light travels at a finite speed. It's not instant. It sure may feel instant. You flick the light switch and the light appears. It's because your eyes can't pick up how the light is traveling. Light is both a particle and a wave. And it travels very, very fast. But in the vastness of space, it takes time. Our sun, as I said before, it takes about 8.4 minutes for sunlight to get from the sun to the earth. So when you go outside, you're actually feeling sunlight that's 8.4 minutes old. It's actually older than that. It's taken a while to bounce out from the inner core of the sun to the surface and then out, radiating everywhere. But all these little points of light are different distances away. Some of them may not be there anymore. They may have exploded. We just don't know it yet because we haven't seen the explosion. So you are a time traveler when you look at the sky. The coolest thing, again, if you're at least 4.2 years old or older, is to look at a star that's as far away as you are old. Now, what do I mean by that? We're gonna pick a star. I don't know the number off the top of my head. I'm gonna pick Betelgeuse just because it's sitting right there and I see it. Distance is 497 light years away. Do you know anybody that's 497 years old? I don't. That doesn't really work. But we're going to ignore that number. Let's imagine, let's do a thought experiment. I believe my professors back in college used to call it Gedanken experiments, a thought experiment. Let's imagine that Betelgeuse is 30 years old. So that's lie number one. This is not true, but let's say it's 30 years. 30 light years away. Let's say tomorrow's my birthday. It's not. Let's say tomorrow I turn 30 years old, and this star happens to be 30 light years away. I go outside tomorrow night, not my real birthday, and look at this star that happens to be exactly the same distance away as I am old. What am I looking at? If I turn 30 and look at a star that's 30 light years away, when I look at that star, I see the light that left the star the day that I was born. I'm looking back in time to my own birthday, at least from that star's point of view. That's a strange mental thing to think about. So if you know someone that's 12 years old, you show them a star 12 light years away, they see the sky, that star, the way it was the day they were born. Or maybe you're a 97-year-old grandma. Show her a star 97 light years away. That's the way that star was the day she was born. Astronomy is a time machine. It's an existential crisis creator. It's a thought bubble. It's dread and it's inspiration. Balance. And so with that very strange thought, we're going to go ahead and end our show. If you have questions, again, you can post them here. We have a Facebook page. We have a YouTube page. Hopefully there's comments there. I don't see any popping up here, but that's okay. We now multi-stream. You can find us on YouTube. You can find us on Twitch. You can find us on Facebook. Those links are on the Twitch page, they're also on the YouTube page, they're also on the Facebook page, so wherever you're looking at us, click on the other ones, like and subscribe to the channels. Use whichever medium you prefer. Some people don't like Facebook, some people don't like to really use YouTube, some people don't even know what Twitch is. That's okay. Whichever one you want to use it! That's why we're multi-streaming this time. Multi-stream. Please share our channel. We just want to get the word out there. I want to teach people. I spent 7 years teaching astronomy in a planetarium. A couple more years teaching at a university. And then 10 very dark, sad years trying to be a business person, but I'm not cutthroat enough for that. Because I know that there's a lot more to life than being the winner in every single business transaction. So it would be appreciated if you shared this channel to other people, get more people viewing. If this time slot doesn't work, I am more than happy to change it. Right now we do shows every Monday, Wednesday, and Friday at 1 o'clock. If you think more children will be around or more adults will be around at a different time slot, I'd be happy to move this, because I just want to get more people interested, more people talking about it. Chat notification, what do we got? I love learning so much today, even in and out of sleepiness. Yep, it's okay. People are sleepy. Some people have night jobs. Some people stay up all night, like myself. At least I used to. The goal is always to invite people to sit around the fire. And the fire, in this case, is our digital medium, our cell phones, our computers, whatever it is, and we just talk. We talk about sky stories. We talk about planets. Today was much more of a scientific show. I didn't really talk a lot about stories, just because I didn't. We can always do that. The problem with some of the stories is that they're not always the most PG, and you know, depending on the age groups, it's never fun to talk about, you know, various deities assaulting humans, because that's usually how the stories tend to go, or they're just humans being abused by deities and either thrown up into the sky and turned into constellations, or they're just like brutally murdered and then thrown up in the sky to be a memorial. Like, it's just never fun. Well, I appreciate your roommates and you sticking around and watching. Again, this is more of a, right now it's kind of a service that I'm trying to provide. It's something I'm just trying to do to keep my brain active and do what I do best. I'm an astronomer by trade. For those of you that are maybe new to the channel, my name is Mike. I have a degree in astrophysics and a master's degree in business, which in some cases I feel like I regret. I did learn a lot, but I also never really fit into that because oh god, I dropped my ring. That's not what I wanted. I never really fit the mold of the cutthroat business person. I really wanted to just do something different and become a well-rounded person. So I know a little bit about everything, but not a lot about some things. That's good and that's bad. I love to talk about astronomy. I love to talk about, you know, the cultural impacts. You see astronomy all around you, whether you believe it or not. You feel it. Lots of technology developed to keep people safe in space. That's related to astronomy. Your Gore-Tex and other, you know, superheating things, you know, freeze dries foods and all that stuff. That's all astronaut ice cream, stuff like that. Like that stuff. That's all, you know, astronaut ice cream's not a real thing, I guess, but you know, it's all related to people wanting to go to space. You got new technologies, we got battery stuff, you know, battery technology is getting better, so we got better stuff for the space station. Now we got battery-powered cars, we're getting cool new rockets, we're developing new ways of traveling. Ion drives hopefully will one day come online and we'll be able to travel around. Right now it takes, you know, 18 years or so to get from the Earth to, like, Pluto. That's not very fast. It takes, like, you know, an entire kid being born all the way through their high school years just to get to other planets in some cases, in our own, or dwarf planets in this case, in our own solar system. What's going to happen when we're actually able to travel around? Are we going to be able to go out and mine things? There are asteroids that are floating around in that asteroid belt that we looked at that are worth hundreds of times the economy of our entire planet. And they're just floating out there. Can we make mining colonies on these other little worlds? Can we travel around? Will we ever meet other things? Of course, I always get a lot of people say, well, we don't even know a lot about our oceans. Yeah, I know, we don't. We should. I myself, I prefer the stars. I want to travel the stars. I'm afraid of the ocean. There's creepy things down there. Cthulhu's down there. In a weird way, embrace the void. Become one with space. Study the stars, study astronomy. Hopefully I raised a couple things in your mind that maybe you never thought about before. Maybe you want to learn more about it. Again, astronomy picture of the day. Start there, click around, look at some pictures, be in awe, and then go down the rabbit hole of clicking on links and traveling around. Again, in about a month, on the 18th in February, we'll be looking at a Mars rover landing. If you've never seen one, that's actually a good possibility. There's only been 4 landers that have landed on the planet Mars from NASA that have actually survived. You got the Mars Sojourner rover, which was literally just a little toaster that landed with Pathfinder. And then you had Mars Exploration Rover, Spirit A, and then Opportunity was B. Those landed in 2003. And then in 2011, we had Mars Curiosity. And they've been getting bigger and bigger and bigger. You went from a toaster to something the size of a golf cart to something the size of a Volkswagen Golf. And now you got a bigger one that's actually even got a companion. This new rover has a helicopter on board. A little helicopter drone that they're going to fly around Mars. And that just sounds so dang cool. And if you don't know anything about those things, you know, go learn about them. We'll talk about them here. We'll probably talk about them on our Friday show. I'm mostly just hyped about that because I actually just finished writing and scripting the next video that I'll be making, and it'll be uploaded and ready to go, but it won't actually appear till February 1st because it's the monthly Sky update. And I actually think I need to re-upload the January one because I don't actually see it in the queue here, which is dumb. So I'm going to redo that. So if you like watching videos, I try to put some videos up every couple of weeks. This is kind of a one-man, or actually a one-man, one-woman show. My wife and I, we do this ourselves. I do the shows live. She helps with some artwork and with some technical aspects of things on the backside. It's a 2-person show. We're doing the best we can to churn out stuff to help intrigue you. If you could share the channels, we would appreciate it. Like the Facebook page, things like that. I'm glad the dog finally settled down and stopped being a growly, grumpy dog. We do appreciate you sticking around. Please have yourselves a wonderful afternoon, evening, morning, whatever it happens to be where you are. Take care of yourselves, take care of each other. May you have clear skies and lots of love. We'll see you next time.